Dealing with a couple of things today. The main thing is we're going to start off by looking at transformations of logarithmic functions. We're also going to be looking, though, at something called the change of base formula. And we're also going to be solving logarithmic applications. The nice thing for you is the logarithmic applications we're looking at solving today or working with are not ones where we have to come up with the equation. It's not like trigonometric applications or exponential applications where you have to build the equation. That will come a little bit later. So we'll start off with the following situation. We have a logarithmic function log base 3 of x plus 9 plus 2, and we want to be able to identify what this graph looks like without using a graphing calculator. And the reason why we're able to do that is we're able to understand that this is a transformation of y equals log base 3 of x. It's a very basic transformation. It's taking the graph of y equals log base 3 of x and translating it 9 units to the left and 2 units up. Would you agree? Okay. So we have to start off knowing what y equals log base 3 of x looks like. And we should know, hopefully, that log base 3 of x as a function has a vertical asymptote on the y-axis. Okay. Now I'm going to take a little detour here. I would go this far actually. You should also know that there's an x-intercept of 1. You go up 1 and it triples. You go up another 1 and it triples again. So you should know that that's what that looks like. And I don't think it's even worthwhile to sketch the curve. By the way, this would be at an x-coordinate of 1/3. I don't think it's worth our time to sketch it. If you don't know what that looks like, then you have to go back one layer deeper. You have to go even deeper than this and say that the function we are after is a transformation of log base 3 of x, and log base 3 of x is the inverse of 3 to the x. And then you have to say, okay, well, 3 to the x has a y-intercept of 1, and you go over 1 and it triples, and you go over 1 and it triples again. So this is what y equals 3 to the x looks like, which means log base 3 of x is a reflection in that line, which means this is log base 3 of x. Do you get my meaning here? Okay. But I don't think that's really that important. What's important here is you understand that this asymptote on the function that we are after is going to be over here at -9. Because everything is translated 9 units to the left. The new asymptote is going to be over here. All of these points will be shifted 9 units to the left, but they're also shifted, is it 2 units up? 2 units up. So this particular point is going to be 9 to the left, which will put it 1 away from the asymptote, and it will be up 2. It's not a difficult problem, this example. This one will be 9 to the left, so it will be 3 away and up 2. Where was that? That was there. This point will be 9 to the left, so it will be 3 away, and it will be up 2. This point will be shifted 9 to the left. So we can count it off if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 up. We could do this last point if you want to. I don't think it's really necessary. but 9 to the left is going to put it here. 2 up will put it here. So that's the graph that we're looking at. Rough sketch, and again, you know, I think how I feel about this. I wouldn't worry too much about getting it perfect. That's what it looks like roughly. The goal with this is not necessarily that you can do this on paper. The goal is that you ought to be able to figure out what the equation of the asymptote and all of this other information is by using transformations. So what is the equation of the asymptote? It will be at x equals -9. What is the value of h in terms of translations here? -9. I hope you learn that the asymptote is always going to be at x equals h. What is the domain and range? Well, the domain is going to be x is greater than -9, and the range is y is any real number. And I hope you note that that's x is greater than h. Will it always be x is greater than h? Well, it won't. When will it not be x is greater than h? Hunter? If there's a horizontal reflection, so if there's a parameter of b involved here, and by b I don't mean the base of 3, I mean that b that the horizontal stretch factor is the reciprocal of. If b is negative, then this would be x is less than h. To find the x and y intercepts, we don't use the graph, we use this equation. So what is the y-intercept? The y-intercept is what you get when you put 0 in for x. Right? That's what we do. It doesn't matter whether it's exponential, logarithmic, trigonometric, quadratic, polynomial. Here's how you find a y-intercept. And this is y is equal to log base 3 of 9 plus 2. Well, log base 3 of 9 is the exponent to which you raise 3 to get 9, which is 2, and 2 plus 2 is 4. And if you go back and look at your graph, you can see that the y-intercept was 4. While I have your attention focused here, I hope you see that the x-intercept is a smidgen more than -9. Okay. So we get a y-intercept of 4. I'm going to use coordinate pair to describe that. And the x-intercept is found by taking the equation and changing y to 0. And this is something we can solve. This is very similar, Addison, to the question you had asked about rearranging, and I think it might have even been an x-intercept, except that the equation we were solving for your question, there was no 2 here. So all we did was we said 3 to the 0 equals this x plus 9, and I realized it was different. Here we just have to move the 2 over first. So we're going to get -2 equals log base 3 of x plus 9, which means 3 to the -2 equals x plus 9. I've just written it in exponential form, that's all. So that means that x is equal to 3 to the -2 minus 9. 3 to the -2 is 1 over 3 squared, which is 1 over 9. You can use your calculator. I'm just going to do it in my head. I believe, though, if you can check, that it's -89ths. So x equals -89ths. That's the x-intercept. And if you figure out what that is, I believe it's -8.8 repeating? No, I don't know. Is it -8.8 repeating? Which is a little bit, it's that smidgen more than -9. Okay. All right, let's try another one. Use transformations to sketch the graph of this function. This function is a transformation of y equals log base 2 of x. I just want to make sure you have a base 2 logarithm for b. Okay. You should know, and whether you want to sketch this entire graph of log base 2 of x or not is entirely up to you, but you should know these key points for y equals log base 2 of x. I hope. If not, then you have that added layer that you have to go back to and say, well, it's the inverse of y equals 2 to the x, so I'm going to sketch y equals 2 to the x and then reflect it. But it's better if we can just land at this point right away. Now what we have to do is understand that this function, I'll put it in red, y equals negative 1 log base 2 of 2 times x plus 3 has been reflected vertically, has been stretched horizontally by a factor of a half, and has been shifted 3 units to the left. There's a negative in front, which means we reflect this thing. We also shift it 3 units to the left, and we also stretch it horizontally by a factor of a half before we shift it. So, to begin with, I hope it's clear that if we're going to shift it 3 to the left at some point, the asymptote's going to go along for the ride. Right? So let's just start doing this. I'm going to take this point, I'm going to reflect it vertically, and I've done that. I'm going to stretch it horizontally by a half, which will put it here, and then I'm going to shift it 1, 2, 3 to the left. So I've reflected it vertically, I've stretched it horizontally, then I've shifted it. I'm not going to worry about this point, because if I stretch that point here horizontally by a half, it's just going to be very, very close to the asymptote, and I'll worry about that later. So we'll take this one. I reflect this vertically, I stretch it horizontally by a half, and then I shift it 1, 2, 3 to the left. And I think you've done enough transformations that you understand this is going to have a vertically opposite curve compared to the original, and it's going to be kind of squished horizontally so it's taller. Do the next one. We reflect it vertically, stretch it horizontally by a half, and shift it 1, 2, 3 in this direction. Let's do one more. Reflect it vertically, stretch it horizontally by a half, which will take it half as close to the y-axis, and then move it 1, 2, 3 to the left. So this is what the function looks like. I didn't do it justice close to the asymptote there. It should be closer, but we don't care. And now let's answer the questions. Domain, range, and intercepts. So what is the equation of the asymptote? It's at x equals negative 3. What is the domain? X is greater than negative 3, and the range is y is greater than, y is any real number. Are we okay with the description of the asymptote and the domain and range? Okay. The y-intercept. Well, the y-intercept is found by changing x to 0. So we'll have y equals negative log base 2 of 2 times 0 plus 6. I hope it's clear here that I factored the 2 out over here in red because we need to see what h truly is. I don't need to go with that version of it, though. I can leave it as 2x plus 6 here. So I end up with y is equal to negative log base 2 of 6, which is the exponent to which you raise 2 to get 6, and then multiplied by negative 1. Okay, so would you agree it's not 4? That log base 2 of 6, that this is not 4, because 2 to the 4 would not give you 6. Would you agree it must be equal to something less than 6, or less than 4 even? Is this equal to 2? Is 2 to the 2 going to give you 6? No. Is it equal to 3? No, 2 to the 3 gives you 8. Do you see it's a number between 2 and 3? Okay, we'll come back to that. And there are a couple people yesterday at lunch that I taught how you can find the decimal value of this. Okay? And we're going to learn that in a bit. But it is some number between -2 and -3. And if you look at the curve that I've drawn and you look at your curve, that certainly makes sense. All we can do here is say that the y-intercept is negative log base 2 of 6. That's all we can do. I mean, you could plug away on your calculator trying different decimal values and try to pin it down, but we won't worry about it. What is the x-intercept? Well, the x-intercept is found by letting y equal 0. I'm going to multiply both sides by -1 to get rid of that negative. Now I can write it in exponential form. And solve this equation. Can you solve that equation for me and confirm that you get x equals -2.5? Subtract 6 from both sides to get -5. Divide both sides by 2. You get -2.5. So the x-intercept is at -5/2, comma 0. And that makes perfect sense because if you take a look at the graph, that's where that x-intercept landed. So the only reason why I include the second example of a transformation is I'm going to use it to explain to you how we can find the value of this number, log base 2 of 6 times -1. Okay? Now, there's this, on your formula sheet, there's this change of base formula, and this is what it looks like, and I know it can be confusing, but I'm going to give you a different example here. Log base 2 of 64. You should be able to figure out what log base 2 of 64 is using your knowledge of powers of 2. And I see some of you going 2 to the, 2 to the. It's 6, isn't it? That 6 is the exponent to which you raise 2 to get 64. But, so this is 6. Take your calculator, and I didn't mention this yesterday, but this log key, this is a base 10 logarithm because there's no base attached to it. Take your calculator and take the log base 10 of 64 and divide by log base 10 of 2. You do have to close those forced brackets that are spit out whenever you hit log. So log of 64 divided by log of 2. What's 6? Well, it's not a coincidence. What I'm telling you is that will always be the case. And that's what this is saying. This is saying, if you want to know the base b logarithm of c, and you can't figure it out, then use a base 10 logarithm. Change it to log base 10 of c over log base 10 of b. It's always log of the argument over log of the old base. So we are asked to consider these four and rank them. And I believe there was a question similar to this in yesterday's handout, but most of them you could figure out. So what are these equal to, approximately? Listen, I honestly believe you should understand log base 6 of 24 is a number between 1 and 2. Because 6 squared gives you 36. And 6 to the 1 only gives you 6. But log of 24 over log of 6. This is approximately 1.77. I think with a bit of thought, you should be able to figure out that log base 3 of 66 is going to be a number between 3 and 4, because 3 to the 3 is 27, and 3 to the 4 is 81. .8 approximately. I think you should understand that something like log base 10 of 3 is going to be a number between 0 and 1. So it's going to be some kind of a root of 10. But we can figure out what it is. Log 3 divided by log 10. While I'm here, I'm going to do log 5 divided by log 20. So about 0.48 and 54. So ranked in order from least to greatest would be expression 3, then 4, then 1, then 2. Good? Okay. Now, how many of you use your calculator in the mode where if you use the exponent here, it doesn't do that, but it pops it up to a higher level? Okay. I don't use that, but can I open 2? I think I should be able to open 2. Yep. I'm going to put mine in that mode that I just don't like, math print. And, you know, some of us have calculators that we use that you don't have math print. So you're just an observer here. If you're in math print mode and you go to your math menu, what I'm about to show you, you cannot just lean on as a crutch all the time. You have to keep your brain sharp. If I say, what is log base 2 of 128, I think you should figure it out without what I'm about to show you. Okay? But if you go to your math menu and scroll down, you have something called log base. And if I go here, I have log base. It's still there. The difference is when I enter it here, I just get this thing, which I will explain to you in a second. If I enter it here, I get the opportunity to put in the base in the argument. So I don't have a base 2 log key. I don't have a base 8 log key, but in a way I kind of do. I can enter log base 6 of 24. And I get that number. Now, so I don't have to use the change of base formula. How many of you have a calculator that you can put into that mode, but you don't use that mode, usually? If that's the case, and you need to use it, just convert it to that mode and then go back. I think in this situation, and I'm going to go by memory because I don't normally do this. I think what you do is this. I may have it backwards. I think you enter the argument followed by the base. It's a syntax thing. Yeah. So you still have the opportunity, even with, I think, a TI-83, log base is still there, isn't it? Does anybody have a TI-83 that you're using? If you go to the math menu and scroll down, because is log base still there? I think it is. I don't know. Maybe not. It's not, eh? Okay. So you have to work around that. And that's, I think, why we give you the change of base formula on the formula sheet, is there's no guarantee that you have this option. Even though I have that option, I always just revert back to the change of base formula. I think, quite frankly, it's just as quick. Log 24 over log 6. What this means, by the way, is we could have graphed something like this function on our calculator. But what I would do is when I go y equals, what I would do, because my log base is disabled, is I would go log of x plus 9 over log of 3. And I got to close the bracket. I thought I did, but apparently I didn't. So what I've entered there is log base 3 of x plus 9. And then I go plus 2. If I use my other calculator, I could go and choose the log base option. But I want to show you something here. Log base, it's base 3, and it's of x plus 9. And then it's plus 2. Okay. So I'm going to go zoom standard. And zoom standard. And I get the same graph. The issue is this. It looks like a square root function. It looks like it's starting at that point there, and it just, out of nowhere, it blinks into existence and then does that. The graph actually goes down against that asymptote, right? This is what I meant earlier when I said your graphing calculator does a horrible job of graphing logarithmic functions. The reason is it's so steep. Your graphing calculator basically generates a table of values in its brain. It takes an x coordinate, calculates y, and plots it. Then it moves over a little bit and calculates the new y coordinate. But because it's so steep, it can't plot all of those points. It's missing them because it goes from this point where it's way, way down here to this point where it's up a bit more, and it just doesn't come out right. Anyway, that is a useful feature to have. Is there anybody who has a TI-84 calculator and you don't have that option? Ethan, do you remember what it was with your calculator that we said we were going to, was it you? Whose calculator was it that was an 84 but you couldn't do something? You remember what I'm talking about? Had something to do with fractions maybe or something. If you do have a TI-84 calculator and you go to math print and log base is still not there, we just have to upgrade your operating system. Let me know. Okay. We have a couple more questions to do. Determine the domain and the intercepts of this function. So this function is 2 times log base 3 of 3 times x minus 5 plus 4. That's the domain. There's another way I can explain to you why this is the domain that we will worry about next week. That's maybe a more broad idea. But for now, the asymptote of this function will be on the y-axis shifted 5 units to the right because h is 5. And the function curves against the asymptote away from it on the right-hand side. What about the intercepts? Well, this is just a little bit more practice to find an x-intercept. We have to solve that equation. And then to find a y-intercept, we're going to put 0 in for x and solve for y. In order to solve this for the x-intercept, I subtract 4 from both sides. I then divide both sides by the coefficient of 2. And really, this goes back to Addison's question at the beginning. How do we get that x-intercept? It's a little more work here because there's other numbers floating around. 3 to the negative 2 will equal 3x minus 15. So we're going to have to take 3 to the negative 2, add 15, and divide the result by 3. And sometimes it's okay to be a little lazy with this. 3 to the negative 2 is 1 over 9. I need to add 15. Now I need to divide this by 3, and I'm going to convert it to a fraction. It's 136/24. 27ths is the x-intercept. What's the y-intercept? Well, we put 0 in for x. And if I put 0 in for x, I'm going to have the y-intercept as 2 log base 3 of negative 15 plus 4. Are you with me on that? Where I'm getting the negative 15 from. I'm finding a y-intercept, which means x is 0. Now think about well, let's try it. Let's take your calculator and figure out what log base 3 of negative 15 is. You can use the change of base formula. You can use the log base function. And whatever error your calculator is throwing at you is not because you've made a mistake. This leads into something very important for next week. Log base 3 of negative 15 is asking you to answer this question. To what do you raise 3 to get negative 15? Well, you can't get a negative by raising a positive base to any number. It will never work. That's why, for example, the function 3 to the x is always above the x-axis. It's always positive. And what I'm going to tell you right now is you can never take a logarithm of a negative. It's impossible. You can't take the logarithm of 0 and you can't take the logarithm of negative, which means there's no y-intercept, which, you know, I hope makes sense to you because we've said that the vertical asymptote of this function is over here at 15 and the graph curves away on the right-hand side. There cannot be a y-intercept. Okay. 2 more. You're going to be encountering on exams and the diploma exam potentially problems where you were given a logarithmic equation connecting two things in the world and asked to use it. So I know that some of you take welding, and I know that you typically don't use welding glasses anymore. You use electronic welding shields. But a welding glass is a piece of glass that's very, very difficult to see through. How many of you have ever looked at a solar eclipse through a welding glass? It's a number 14 welding glass. And if you look through a number 14 welding glass and you try to walk around, you're going to get hurt because you can't see anything. It blocks a very, very large amount of light. This is the equation that relates what's called the shade number of a welding glass to the proportion or fraction of light that it allows through. So if, for example, only 1/3 of the light is allowed through, T is 0.3333. Okay? The question is this. If you have a number 14 welding glass, what is the proportion or fraction of a light that goes through? This is just a math problem. We're just going to put 14 in for S and rearrange this for T. So we have 14 equals negative 7 log T over 3 plus 1. On exams, when I encounter a formula very often like this, the negative is put with the logarithm and then there's brackets and there's, say, a 7. But 7 times negative times log is negative 7 log. It doesn't matter where you put that negative. So how are we going to solve this? Well, I'll just put it to you that what you need to do is worry about getting this thing by itself. So you could then write it in exponential form. This is easy. You're going to subtract 1 from both sides, multiply both sides by 3 to get rid of the 3 on the bottom, and divide both sides by negative 7. So 14 minus 1 gives you 13. 13 times the 3, well, I'll do this in steps. We have 13. No, I'm not going to do it in steps. Can everybody agree think about it for a bit, use your calculator if you have to, that when you subtract 1 from the 14, then multiply the result by 3, then divide by -7, you get this number. Okay. This is equal to log of t. By the way, how many of you are in Chem 30 right now? Probably a large number. Have you done pH? You're using logs there, right? So in chemistry, when you see negative log of the hydronium ion concentration, they don't write a base, do they? Do you know what the base is? It's base 10, right? Which is what we learned yesterday. So this is a base 10 logarithm. All we need to do to find t is take 10 raised to whatever -39 over 7 is, and this is t. It's going to be a very, very tiny number because the number 14 welder's glass blocks almost all of the light. (2.68 times 10 to the -6). Which, I mean, if you multiply by 100, it's like 1,000th of a percent or something of the light that goes through. Another way to look at this number, and I can't help myself. I can't just do the math. I have to, explain something. That's the proportion of light that is blocked. Number 14 welder's glass blocks 99.99973% of the light from getting through. I want you to notice, though, that I didn't have to type in this. I didn't have to do that. I could have just taken -39 divided by 7 and done second log. The inverse operation of a base 10 logarithm is 10 to the. It's 10 to the x, which is why when you're working in chemistry, you go second log, or do you still call it anti-log? No, you go second log, okay. And then you could have just said of the answer. Let's do one more. There's a mathematical relationship, and it turns out to be logarithmic, between butterflies and flowers. And the first time I saw this, I went, come on. Nah, some math teacher writing a textbook came up with this, just made it up, but it's true. In one study, biologists or scientists found that the relationship between the number of different flower species in a meadow and the number of butterflies they count is connected by this equation. And I did a little bit of research, and this is the graph from the study. I mean, it's almost perfect. It's not perfect, but it's very close to being perfect. And the question is, how many butterfly observations would you expect if there are 25 flower species? It's just a math problem. You're going to put in F equals 25 and solve for B. That's it. Again, I'm sorry, but this is a Math 30 course. I would expect that you should be able to find out what log B is equal to by taking 25, adding 2.641, and then dividing the result by 8.958. I'm not going to write down every step. So 25 plus 2.641, divide by 8.958. Just want to double check my addition and the numbers I entered. Looks okay. Don't forget this is a base 10 logarithm because it doesn't specify what base it is. So the answer is the number of butterflies will be 10 raised to that, a little over 1,000. So 1217.9. Now you can't have 0.9 of a butterfly. Well, actually you can. You just smush it at the 0.9 mark. But in a question like this, it might be like one that somebody had asked about the other day about rounding, where it might just say to the nearest 100, how many butterflies are there? And if that were the case, then we would say 1200. Okay? If you just want to round to the nearest number here, it's 1218. But I think everybody realizes that no matter what the study says, nature is not going to follow a mathematical model perfectly anyway, right? That's it. There are all kinds of logarithmic relationships. If you crack an egg and you crack the egg open onto a flat surface, you know that thick part of the white? There's a runny part that spreads out, and then there's a thick gelatinous part. If you measure the height of that in millimeters, you can throw it into a logarithmic equation and find out how many grams of protein are in that egg. There's all kinds of interesting things that you might encounter. Anyway, that's the lesson for today. A number of questions on the following pages.